Alright, we are going to start part 2 of Unit 2, and part 2 is over ratios, proportions, and percents. So some of this should be a review, if not all of it, a review of things that you've done in the past. So we're actually going to start this video out with just knowing how to simplify ratios, and just simplify simple ratios and also unit conversions. So we're going to get started with a few definitions. First definition that you see there is ratio. Ratio compares two numbers by division. Now there are a few ways that you will see this written. Probably the most used is the fraction a over b. So you can compare a to b. That's an example of a ratio, and the easiest one for most people to simplify because it is just simply a fraction. Or you may see it as A to B, and you can also see it written with the word to, A to B. So if you were comparing boys to girls and how many boys are in the class compared to how many boys or girls are in the class, you could either use any of those three forms for ratios. Now another definition that you see there is rate, a ratio that compares quantities measured in different units. So when we talk about rate, hopefully the first thing that you think of, or one thing that you think of, not necessarily the first thing, but miles per hour. That's a rate that everyone deals with every day when you are driving, or even if you are in track, you're going to talk about your rate or your speed. So that's a ratio. It compares quantities that's measured in different units. And then unit rate is a rate with a denominator of 1. And what that means is if you have a miles per hour, you're going 55 miles in 1 hour. So that would be an example of a unit rate. But if we were to talk about you drive, or maybe you run, that would be a better example. You run 300 yards in 30 seconds, that would not be a unit rate because your denominator is not 1. You would have to convert that and simplify your ratio down until you get it into a unit rate. So let's look at this example where we have unit rates that we need to write. In this example, you're shopping for t-shirts, and you've got 3 different stores to choose from. Store A, B, and C, and they each have a different deal. So what we want to decide is we want to figure out which one has the best deal. Now some of you all can do this different ways, not necessarily with unit rate, but you could look at this and say, for example, I would look at this and say, $25 for 2 shirts, but for $5 more at store C, I could get 3 shirts. So store C looks like a pretty good deal. But then this one, $25 for 2 shirts. This one has $45 for 4 shirts. So if I had to add 2 more shirts at store A, that would cost me $50. So more than store B. So you can make a good guess just by analyzing those, and what some of you all may do when you go shopping, what you've got there. But let's actually look at our unit here. Let's look at store A. Store A, you have $25 per 2 shirts. I'm going to use S to represent shirts. So $25 per 2 shirts. So if I wanted this, thinking back to your definition over here that we had, if I want this, my unit rate, where my denominator is 1, then I need to set this equal to, I need to simplify this fraction. Think back to really elementary school and simplifying fractions. We need to simplify 25 over 2. Same thing as dividing 25 by 2. Okay, we're going to divide our numerator by 2. We're going to divide our denominator by 2. That's why we wind up with 1 as our denominator if I divide the denominator by 2. So 25 divided by 2 would give me $12.50. So at store A, if I want to buy just 1 shirt, it's going to cost me $12.50. So let's think about store B. Store B, for $45, I can get 4 shirts. So let's change this unit rate so that we have a denominator of 1. So to get a denominator of 1 here, I would have to divide by 4. So that's where my 1 comes from. So then 45, which is my numerator, divided by 4, this is going to cost me $11.25. So what I was thinking a while ago about my store A and store B, I'm actually right there. Store B is cheaper than store A. So let's go ahead and move on. Let's look at store C. Store C offers for $30 I can get 3 shirts. This one actually is a little bit easier than the other ones. Change this to the correct rate here. For 1 shirt, I'm going to pay $10. So based on these ratios, which store has the best deal? Well, the store with the best deal is obviously going to be store C. For only $10 I can get 1 shirt, whereas with the other 2 stores I'm going to be paying more. So changing to unit, the correct rate there. So let's go on. I want you to try this one. Pause the video and see if you can answer this question. You may have to go back and look at your notes for what we did with example 1. Okay, so for this example, all they want us to do is store B is going to lower their price. Now, not by much, but they are going to lower their price to $42 for 4 shirts. So we want to see, is that going to change our answer from example 1? Would we rather shop at store B rather than store C? So let's figure out what this is going to cost us. For $42 at store B now, we can get 4 shirts, so a little bit cheaper. So if I change this to my units here of denominator of 1 for 1 shirt, now that it only cost me $42 for 4 shirts, the price per shirt is down to $10.50. So does the solution change? It does not, because in example 1, store C, it only cost me $10 for 1 shirt. And even though store B lowered their price, it's still 50 cents more expensive at store B than store C. So your explanation would just simply be that store C is still cheaper. So no, it does not change. Alright, so let's look at another definition here, conversion factor. Conversion factor is when you have a ratio of 2 equivalent measures, but they're in different units. Okay, so a conversion factor is always equal to 1. So an example, and this would be a really good example for you to write down, 1 foot over 12 inches. So ask yourself, are there 12 inches in 1 foot? Yes, there are. So these actually mean the same thing. They are equivalent measures, but they are in 2 different units. If you were to change 12 inches to 1 foot, you would have 1 over 1. So your conversion factors will always equal 1. Equivalent measures, just in different units. Okay, 1 hour to 60 minutes. There's you a conversion factor, and again, it is equal to 1. So we're going to look at example 2. What is the given amount converted to the given units? Okay, so for part A, we have 330 minutes, and I want to change that to hours. Okay, so these are actually very simple. You've got 330 minutes, and what you need to decide is what will be the conversion factor that I need to use to convert this. So we're going to multiply this by our conversion factor. Okay, well, we want hours. Okay, so let's think about this, and I just used this example for you. 1 hour is 60 minutes. That's my conversion factor. Now, when we talk about dividing things, we talk about if the top and the bottom have it in common, they will divide out. The same thing goes really when you're converting units. So if you look at this, on the top of this fraction over here, because I could place this over 1 if I wanted to, This unit of measure is in minutes and it's on the top. This unit of measure is in minutes and it's on the bottom. So this is what you're doing when you're converting units. You can actually divide out your common units here, your minutes, and so the only unit of measure left in this problem is hours, and that's what we want for our final answer here. That's what it's asked for. So the way this looks is you've got 330. Maybe I can highlight this to kind of pull this out a little bit. You've got 330 now times 1 over 60. So 330 times 1 over 60, and when you actually multiply those, you get 5.5, and the unit of measure that we have left over is hours. So 330 minutes will convert to 5.5 hours. So you're going to do the same thing here with your kilograms. This one may be a little more difficult if you're not sure about grams and kilograms. But we've got 15 kilograms, and we want to convert that, to grams. So what conversion factor would we multiply 15 grams by? 15 kilograms. Well, 1 kilogram is equal to 1,000 grams. 1 kilogram is equal to 1,000 grams. But if I put 1 kilogram up here, my kilograms are both going to be on the top, and I'm not able to divide them out. So if I want to divide out my common units, I'm going to have to put my 1 kilogram here on the bottom. So 1 kilogram is 1,000 grams. So you have to be very careful with how you design your conversion factor. You want to make sure that you have set up your fraction here where you can divide out, one's on top, one's on bottom, your common units. And again, the only unit we have left now is grams, which is what the problem asked me for. So just like we had in the other problem, we've got our 15, and we're going to multiply that by our 1,000 over 1. 1,000 over 1 is just simply 1,000, so we could just multiply 15 times 1,000, and what that's going to leave us with is 15,000 grams. So 15 kilograms is the same thing as 15,000 grams. Alright, in the next video for simplifying ratios, we're going to start looking at, we will do an example of converting measures just to make sure you understand the conversion factor, and then we'll go ahead and look at something called unit analysis and making sure that you can translate units from a word problem, and your summary question will also be in that video. So please move on to simplifying ratios part 2.